I think it's important to note as we move on through some of these geometry videos that the whole point of geometry is to display logic. Okay? A lot of times you can look at a drawing or a schematic or something that you actually build and see that, hey, this piece over here is the same length as this piece, or this angle is the same as this angle. The point of geometry is to say, well, if it's true here, could we say it's always true for these types of situations? And sometimes that's the case and sometimes it's not. So you have to pay very close attention to detail. Now we're going to look at in this video is basically two lines that happen to cross. That's it. Okay, now they're what we call these in geometry is vertical angles. Okay. But this happens for any two lines that are not parallel that eventually cross. Okay, now this is logic. Okay, what I want you to think about is if I knew this right here was 40 degrees, and I'm just making up a number. It may not be true to this particular drawing, but I'm just going to make something up. What else could I tell about any two lines that happen to cross? Well, let's think about the things you've already learned. Here's a straight line right here. Okay? And if I know this is 40 degrees, and this distance all the way across here is 180, well, then I can figure out this piece over here by just taking 180 minus 40. And that gives me 140 degrees. So this has to be 140. Now, if I follow that logic all the way around, well, that means that this, well, once again, let me use different colors to show you. Here's another straight line. And I know this piece is 140. What's this piece right there? Well, 180 minus 140. And it feels like I'm going in circles, and that's because it's geometry. There's a lot of that. We just have to start recognizing these things so we don't have to always go in circles. I get 40 degrees. Oh, so this is 40. And guess what? If I work my way back around, what do I think that's going to be? Oh, let's see, 40 degrees, and I take that away from 180. Here's 140. Now, when we figured this out, this holds true for every set of lines that crosses anywhere. Okay? As long as two lines are crossing, we can look at them and just kind of break it down, and instead of doing all that math, even though this math over here isn't all that difficult, why bother if we know we can say this is always true for crossing lines? Okay? So if I see two lines crossing and I know I've got an angle here, well, the angle opposite that is always exactly the same. And notice the angle always opposite that angle are going to be the same. Okay, so vertical angles, there's nice. You see a drawing and you see one angle that comes from crossing lines. Before you do anything else, you can fill in a bunch of numbers that weren't there before, but it really doesn't take a ton of math to figure them out. Okay, so vertical angles is something else we're going to look for. In this section, you're working on parallel lines cut by a transversal and vertical angles. And the reason is those things aren't just going to show up now. They're going to show up throughout the entire course. And as you see them, you can start plugging in numbers just because of the logic you know. You don't have to necessarily labor over a lot of calculations, but you can start plugging in numbers, and pretty soon you've got the problem done without even really putting in that much effort.